Chris Steliani for Hobby Game Dev. This is going to be another video walking through some of the programming exercises included in the CodePak bundle. This time, unlike the first video, I'm going to be focusing on the racing game example, which, as shown here, is kind of an old-fashioned, just overhead driving game. This is all that's included in the example, and here one player is the arrow keys, one player is WASD. I'm trying poorly to control both at once. And some of the main functionality, in addition to, of course, the driving mechanics, forward and reverse for each car, is that when you hit the checkered line at the end, it resets. Now, there's a lot missing from this racing game, but with the CodePaks, that's kind of the point. Because the point of the CodePaks, of course, is you get the source code for it, and you're able to use that as the foundation for a bunch of exercises. These exercises shown here in particular. And now, if you don't have these things set up and you're interested in trying it out, once again, you can go to processing.org. It's where you can get the, you go to download processing. I'm using a Mac in this case. The exact same things, including the CodePak bundle, work on PC and on Linux. You go to download it, free download, whatever system you're on. And then you go to hobbygamedev.com/codepaks. You can also go to the old URL, gamecodepaks.com. It's going to redirect to this subfolder on hobbygamedev.com. We scroll down to where the purchase is. Price is actually subject to change. It's going to increase a bit now that making this new video adds some value to the package. And then that's where you just need to go to make the purchase. You do there, fill in your information. You don't have to use PayPal or anything, but then you'll be able to download the file. And if you've downloaded processing and downloaded the CodePaks, you wind up with the processing application, which you unzip, open it up. In the case of a Mac, it's just a single file. In Windows, you'll have a directory of processing files, and just run the executable from there. And the CodePak bundle, which once you unzip it, has the folder with all the different prototype code, the classic game examples in it, the common bonus, the different split versions of the space battle game, and so on. And the install process, in case you missed that in the other videos, is we simply go to where processing by default plants its application files, or under Documents or My Documents in Windows. And inside there, you'll find any sketches you've got. And I just copied in my CodePak bundle folder there. And at that point, when I next open processing by running the application, it shows up here listed under the sketches that it already has visibility on. So if I go to racing, that's how I open up this current project, which when I press play, provides us the following game. Now, processing is Java-based. It's very, very close to Java. There's some very subtle differences, but for all intents and purposes, it's Java programming with some built-in graphical support, so you don't have to wind up fumbling with libraries to deal with sound or basic game input. It deals with a lot of these things for us. But if you want to follow along, you're going to need that CodePak bundle from hobbygamedev.com/codepaks, or you can get that from gamecodepaks.com, along with the processing development environment. Now, the first thing we're going to do, because when we follow along these exercises, it's going to kind of maul our example. We're not going to have the same starting point anymore. And let's say we want to split it off. So to begin with, I'm going to go into my directory, CodePak bundle, within the sketches the processing can see. I'm going to duplicate, or of course in Windows I could copy and paste my directory. Duplicate. Max, I'll duplicate it. I then just want to rename it to racing work, for example. And then remember, the thing about processing is it's looking for one of the files in your source to match the directory name. So I'm also going to rename racing.pd to racing work. And that's going to give processing the clue as to what's the main project file. So because I changed the directory, so we have like a scratch testing area, I've also had to rename the main PD file. If you're not seeing the extensions in your files, as I mentioned in the PDF document, it's going to be good to look up online how to expose your file extensions. By default, most development environment or most operating systems hide file extensions for known file types. It's going to be useful for you to be able to see like what's a PNG versus a TXT file, PD file, be able to rename that and tell when you're game programming. So with that out of the way, just from duplicating the directory, we're not going to see it yet inside of processing because it only updates the sketch list when we reopen processing. So I'm going to quit processing. I'm then going to, I think I still have it. Yeah, I still have it in my downloads folder. Reopen it. And now when I check my open sketches, CodePak bundle, classic games, there's racing work. That's my duplicate of the project. And it knows that the files I want to modify are the ones in that directory, not the ones that are, let's say, documents, processing, codec bundle, classic games, intermediate, racing, work. Okay? It's going to be working on these files because they're in the same directory. It's not in any way connected to the ones that we duplicated to make this folder work. I'm going to leave this folder up because it's going to be handy. Early on, we're going to change some assets, some of the image files. It's going to be useful to have those up right here. Handy for us to get to. Okay, first thing we always want to test is just so when we press play, it checks out. It's not complaining about file name mismatch. It's not no issues in translation. And sure enough, arrows drive blue car, WASD drives the green car. It appears to be working a-okay. Now let's go look at the exercises in the bundle. I'm going to scroll ahead. Looks like Headlights on P2 Car starts on page 59 of our PDF. Let me skip ahead. 59. All right, so yeah, here's the racing section. Each of the games in the code pack comes with its own section. So to add headlights, player 1's car has its headlights turned on, whereas player 2's car has its headlights turned off. Turn the headlights on for player 2. Now you might be thinking, okay, well, I just got to look in the code and find the headlights equals true variable for player 2's car. That's not how it's working. And the details help provide some clarity on what's really going on. This change isn't in the code at all. It's a simple trick accomplished by using a larger image for the car than is needed for the car's body, with the margin space used to partially transparent gradient that when drawn over other objects in game looks like headlight glow. Look in the data folder for the player car images and compare the two images. Turning on the headlights for player 2 can be accomplished by renaming the old player 2 car image in case we want to bring it back later, duplicating or copy pasting the player 1 image, renaming the duplicated image to the name of the original player 2 image, the one that the code's already looking for basically, and then recoloring the car body in the new player 2 image to look different than player 1's. And of course, instead, the edits could be made to the player 2 image directly, extending its dimensions and drawing the headlight glow, but the above series of steps ensures that the headlights on both cars will look exactly the same. Having art that matches in style goes a long way in helping a game look well put together. So let's go and do that. So we can see, at least in our preview, they don't look that different, but if I open these both up in Photoshop, and if you don't have Photoshop, you can of course go to gimp.org and use that. I believe even Photoshop CS2 might be available now for Windows free, if I'm not mistaken. You can kind of Google for that. For our games, it's okay often to use an outdated version of Photoshop, no big deal. But see, if we zoom in on player 2's car, we'll see where it's cropped. Of course, the checkerboard means transparency, pixels that don't get drawn. Whereas player 1's car, it's got a much bigger margin around it. And just to further expose that, let me move in my bar so you can see what I'm doing here. I don't really need this info stuff right there. See, if I paint a layer underneath this, that's a solid color, let's say black. Now you can see that I have sort of a white glow and a red glow for the headlights and taillights here. Whereas if I go into player 2's car and I paint a black layer underneath it, clicked on new layer, spray paint, there it's the car only, plus some bumpers on either side. So in order to make the player 2 image look like player 1's, I'm going to do this. Just like I described in the document. I'm going to rename the old player 2, old. I'm going to duplicate or copy paste. I just need a second file like player 1's. I'm going to rename that to player 2 PNG because that's what the code's already looking for. Next, I'm going to open up both of those. And so what I suggest in the bundle's documentation is you can then come in and recolor this car. But of course, an even easier way to do it is I'm going to open up my old player 2 car image, paste it on top of that blue car, and here we go. I can check by doing a painted black layer underneath it. You can see there I've put the headlights and taillight on it. I'll save it. So I'm saving over player 2's PNG. I'm not going to save that black change. But so now, player 1 and player 2, both their car images should have the lights on. When I press play over in processing, sure enough, you'll see here, the green car now has its headlights and taillights on also. It's just an image trick. It's just a bitmap designed to be centered on where the car is that has the headlights and taillights glow partially transparent drawn there. That was the first exercise. Now the second one, 512. We're going to introduce new tile types for grass and oil slicks. So collision in this game between the cars in the world is handled in a very similar way to the collisions between bricks, the ball in this code pack's earlier brick breaker example. A 2D array of int value stores a different value for each type of stationary ground object in the level. 0 corresponds to open road, 1 to the finish line, 4 to a plain wall, 5 to square filled with trees, and 6 to flag post. I skipped 2 and 3 because those have a special purpose. Where the game code finds 2 and 3, it uses those to determine start coordinates for the player cars, then fills in a 0 for open road during play. These values don't need to be memorized, or even typed in different places in the code, because they're each defined as a different final int at the top of the world tab. Let's pause there for a moment and check at the top of the world tab. You see your plain road 0, goal is 1, player 2, player 3, or player 1 and 2, the wall, tree wall, flag wall. Okay, let's see. This way, instead of checking if the tile under the player's car has the value of 0, we can check whether it's equal to track type plain road. Create 2 new types of level tiles, grass and oil slick. In addition to drawing the tile art, add them to the track map and program special functionality from the cars drive over them. When either car drives over grass, make it move significantly slower. When driving atop the oil slick, don't let the car turn. Okay, we can do this. This exercise consists mostly of figuring out the pattern in the existing implementation so that you can extend it on your own. This sort of pattern matching applies not only to the code but also to the data files involved. For example, a handy way to ensure that your new tile art for grass and oil slick squares are the correct size and format is to start work on them by duplicating or copy-pasting an existing tile in the data folder, renaming the copy, then drawing on top of it. So let's go and do that. Here we can see we can have the individual squares for the track, goal, flag wall, road, tree wall, another piece of track wall. And so what we want to do, we want grass and we want oil slick. Well, oil slick's probably going to go on the road, so let's use that as our starting image. I'm going to duplicate that again from your Windows, copy and pasting it, or you could of course open it up in an image editor like Photoshop or GIMP.org and then save it back with a new name. I'm going to call that track oil. That's going to be one of our new images. And we also wanted a grass one for that. We already have this tree wall which has some grass in it. So let's make it grass out of that one. Track grass. Okay. I'm going to go and open up track grass and track oil in my image editor so we can make these look different. And part of what's nice about this approach, because it's all tile-based graphics, we can always come back later, change our mind to improve how the image looks, and it'll automatically be reflected in our game. But first off, we just want kind of a hasty solution. So I want this grass to all be, basically I want to get rid of the trees. I could make some effort to keep those speckles in here. You can see I've got some sort of little subtle noise. And in fact, let's go ahead and do that. Let's say filter render, where are we at? Filter noise, add noise. We don't want that much. Real little bit. Even less than that. Yeah, it's kind of grassy. A really, really low level of Gaussian noise. Okay. Merge those layers so it becomes a single layer in Photoshop. Save it back over itself. And now for oil, we have this road as a starting point. First, let's put a black blob on there. It's going to look kind of oily. I'm going to change to the pencil tool. Brush tool has very smooth edging, which isn't going to look very oil-like. Go back to black color. And it's not going to be gorgeous. We can always come back later and do something nicer to replace the graphic. You know, one of the easy ways to add kind of a nice bit of detail in this kind of situation is a fake shine. Goes a long way. So I got my white tool. That might be too thick. Single pixel. Yeah, good enough. Okay, so then there's our oil. And alternatively, there's ways you can use a gradient if we wanted. I could do something like bidirectional. Oof. Fade gradient. Use less of it. There we go. Oil slick-ish. Maybe that actually kind of blends in too much. I'm going to undo a few steps. There we go. Oil slick. Making it too complicated for myself. Okay. I'm going to now exit Photoshop. Or at least those two images. And you'll see here in the preview, there we've got the updated images. Okay, we've duplicated and drawn over the old ones, so we already know that they're the right size. They're already the 40 by 40 described in code because we started with the previous tile types images for the work we just did there. Okay. And as it points out here, we could also have just looked in the code and seen that it's 40 by 40 in the code. Now the new track type should be defined as final int at the top of the world file for values 7 and 8. Okay, well we can do that. It's going to look just like these. And this copying of patterns might seem kind of cheap. I mean, you know, like if you were in a foreign language class and you just figured out the pattern to follow and didn't really learn the language, it wouldn't seem legit. But in game programming, this kind of pattern following happens all the time, partly because there's so many different ways to do things. We're often starting from some other foundation or some other existing code base or some project that we're not the only programmer on. So it's really valuable to be able to look at how's it being done here, how can I make mine extend that without having to fundamentally disrupt everything in the way that it's currently done. Okay, we have new numbers now for grass and oil. Their order doesn't matter if you switch 7 and 8, no biggie. Now let's see, as long as they land up to our file. Declare the matching P image after the track flag wall. Okay, let's see. There's track flag wall. P image is, so whereas this is going to be the integer we'll put in our map file to indicate which track type is where, P image instead refers to the handle in memory that we load from the image file with the display when we find that number in the level grid. So track grass, track oil. Once again, the order doesn't matter, but it'd be nice to be consistent with however we did it above. Okay, load the image in load map images. Okay, grass and oil. Again, we can click on the scroll bar. There we go. Here in load map images, it's going to look a lot like these other lines. But of course, we need to replace these with our how we name the files. Let's make sure we don't get a typo. Whenever there's a possibility for a typo between a file name or something, I'm sensitive to. I won't even risk typing it, even whether from memory or looking at it. I like to just use the rename key to get a copy and paste. So here we got grass and oil will be loaded into our new P images. And let's see here. To add test squares to your track, edit a 7/8 into the game track txt file in the project's data folder, since that's what gets loaded in load map layout. So again, if we look at load map layout, it's loading a file called gametrack.txt. That's how it decides where the walls and the ground and pieces go. You can open here gametrack.txt. I'm just going to use a standard text editor, text edit on Mac. Notepad would be totally fine in Windows. It's not a formatted file. You don't want to use something like Word because we don't want a bunch of junk in there about formatting and distances and spaces, italics, bold, headers, none of that. We just want a plain text file, just normal ASCII. And we want to put a 7 and an 8 in there somewhere. Let's put them near the beginning of the map so we can test it more easily. And I think we said 7 was grass, 8 is oil. So let's start off, start off with a 7 here so we can try to drive over the grass there. And we said when you run over oil, you can't turn. So let's put it near this section, 2 little slicks side by side. I'm going to save that text file. By the way, you should also be able to notice the similarity between this layout and the one we saw in game. Like there's 2 and 3 for the players. Here's the 1s for where the track ends. 0s where the road is. And once you've kind of like gotten used to seeing the level in game, you can better see how it corresponds to the data file we're loading. Okay. Let's see, we've added those. In world draw grid, a couple of new cases need to be added to the switch statement. Okay, if we kept our P images in an array, we could skip this step, but we'll look at that in a later exercise. So what I'm talking about here in world draw grid, also still in the world tab or the world file, you'll see each one decides which image to use based on the number that it sees there. So we need 2 new cases. I'm going to copy and paste these 2 cases. I like to hold shift and use up and down to select multiple lines at once. Paste. So our new 2 ones are, we have a grass one, we have an oil one, and that goes to track grass and track oil. Let me double check that's my final ints are track type grass and oil. My images are track grass, track oil. And we correspond to, we want to use this image when it's grass, numbers found, number 7. That image when oil is found, number 8. And then after that switch case statement, it's using that image at that location for the tile has been calculated to display that part of the track. And up here you can investigate the math of how the track gets drawn, or of course some of the exercises I think further explore how to do that from scratch in the write from scratch steps. Okay, there we go, we've done that. Just getting the 2 extra tile types to show up as described in the previous paragraph shouldn't involve much complication. Where things make it a bit messier, since there are many different ways to do it, is in figuring out how you'd like to connect driving over grass or oil to the consequences of movement and control. So then first let's just check and see, are they displaying like we expect? They sure are. You can see here's our grass tile, here's our oil. But so far they just act like walls. Do you see that? We slam into them and stop. We haven't yet handled them as anything, and they're not road, so the game assumes that they're solid based on the code that we have here. Let's see here, when things may get messier. So in update position in the player tab, update position. Here's update position in the player tab, where it's referring to in our document. It includes a demonstration of checking whether the player is driving over empty road or the goal. Okay, here it is. So it's checking what tiles at the player's coordinate based on the speed and the direction they're going in. And if you're hitting the plain road, then we allow the car to update its position. Otherwise, we reset the game if we hit the goal. And so this isn't the, let's see. It's not necessarily the right or only place to make the player slow down on grass or lose turnability on oil. Tile positions are very fast for a computer to calculate, and especially with only 2 cars rather than hundreds, there's really no harm in using what is at this coordinate elsewhere in the player class to check which type of tile is being driven over. Alternatively, the tile player hit value could be pulled up in scope from local to the update position function to instead be a class level variable, making it persist between being computed each frame and accessible to other functions defined in the player class. All that's saying is that this variable, right here we're calling it int within update position. That means that this variable is only accessible within the update position function. But if we move the definition outside of it, kind of sloppily and hastily just like this, now because it's declared outside of the function scope, it's at a class level scope. It's part of the player's class. See up here we have a player class wrapped in the whole file. And so by doing that, we could then reference this elsewhere in our file. But let's instead, I'm just going to revert that change. Here we're deciding what we hit. What if the first thing we do, let's see, here's our speed. Let's first check where we're currently at. So instead of asking where we're going to be after we move, let's check where our car currently is. Tile player is on. Again, we're just to distinguish that here we want the number the car is on top of already instead of the tile the car is about to move on to. And now I can say Boolean is on oil equals, and because we want a true false, I'm going to do a comparison saying if the tile that the player is on is equal to, let's do oil, let's do grass first, is equal to grass, and because this is a final int and defined outside of any class, it's accessible in any of our files. They all just kind of get stitched together into one big mega file when we press play. So now I have this value that's going to be true if the car is driving on grass. Now I can say float speed this frame. By default, it's going to equal speed, but if is on oil, meaning our car is on oil, speed this frame times equals 0.5. It's going to make it 50%, or of course we could also say divide by 2. We want it to be half. Either way is totally fine. And now instead of using the speed to decide the new position for the car, we can check it at only half of its speed if we're driving over grass. Oh, speaking of which, this isn't is on oil. That's is on grass. Let me make this window a little wider so you don't miss any of the code. Silly me. Okay, so there we're checking if we're on grass, then we're going to cut our speed in half. And let's see if that works. So there's my green car. Watch it go. Oop. What's happening is, here we're still only allowing the car to move forward if it's on the road. We also want to allow it to move if it's on the grass. So to do that, I've added some OR bars so that if it's on the road or if it's on the grass, it can still update its position. But its new position is going to reflect the halved speed if it's on grass. What did I do? Oh, plain. There's no plain in it. Copy paste error. Okay, this time, there we go. You can see it's moving and it kind of chugs a bit through the grass. Faster, slower. Now, the effect might be a little more subtle than you're looking for. We could, of course, change that number arbitrarily. What if instead of half, which is what we were doing, if we made it a fifth, it's going to be a lot more punishing to drive over the grass. And a lot more noticeable. Let's make sure it works for player 1's car as well. Let's give it some full speed. Boom. Yeah. So even though it says half here in this document, it's really just kind of a guideline. It's a starting point. I actually kind of like 20% speed here because it's going to be a more obvious punishment or penalty for trying to cut through the grass on a track where we design a layout that allows you to do that. Next, let's look at how they use the oil so that the car can't turn when it's driving on it. So here's where we detect turning left and turning right in our car steering. We have these functions that call steer left and steer right if the car is moving above a minimum speed. And that makes sense, of course, because cars, unlike bulldozers or tanks, can't spin in place. They have to be moving forward or backward to turn. So that's why that's there. But what we want to do is we want to deny the car the chance to turn if it's sitting on oil. So let's do this. Just like here, we had a couple of lines that checked which tile is it on and is that tile grass. I'm going to come back up here and ask here, what tile are we currently on? Is that tile oil? Of course, we don't have to make a whole separate variable for this. I just find this makes the logic a little more easy to use. We could say if it's equal to false, then let us turn. But at that point, whenever we start layering negations, it can become very confusing. So I like to think instead of is it not on oil, then I can put the not equals here. And this makes for a more semantic, logical statement. Check the tile the player's car is on. If that tile is not oil, this will be true, is not equal to oil. So if the player is not on oil, let them turn. Okay, and we can duplicate that same logic here by copying and pasting. Now, maybe this is a bad idea because now I've got the exact same code in both places, right? That's a little ugly. So what I'm going to suggest we do instead, we don't have to, but just to stay organized. Private void. What I could do here is I could actually write a Boolean function that'll return true if we're not on oil, for example. And then we could check that same function both places. But because both left and right also check if our speed is above a minimum, I'm going to make this function a general case for can I turn. So watch this. Can I turn? So if our speed is less than or equal to the minimum turning speed, return false. See how I negated that? Because instead of saying allow it if it's greater than, I'm going to say if the total speed is less than our minimum speed, don't let us turn. Okay, now the next situation that comes up, we want to think about can we turn, meaning are we not on oil? Which we already have the code for that because we wrote that elsewhere. And now I could say if we're not on oil, meaning that we're not on oil, we're allowed to turn, so we could return true, and else, meaning that we're not on oil, I could return false. This is, of course, a really verbose way of doing just one thing, returning as not on oil, because having already ruled out that we must be going above the minimum speed, now whether or not we can turn is simply a matter of if we're not on oil, we can turn. But having written this helper function, I can now simplify and declutter the steering left into simply asking if can I turn returns true, which we're allowed to do because the return type here I used is Boolean instead of void. So it makes it sort of a useful little helper function. And I can ask the exact same question for turning right. And part of what's nice about this is in addition to reducing sort of code reuse or just copy and paste error potential, if I want to later redefine the conditions for being able to turn by something more strict or something more involved, maybe if based on when there's going to be a wall in your way, I could do all that complication here in can I turn and left and right, we're both automatically going to share it. Now, the other thing to look out for is because so far, let's show it right here. Drive over the grass. I once again can't drive over the oil because it's not open road and it's not grass. You'll see how once again we're starting to stack up these definitions. Where is this? Update player position. There. We said only let the car move if it's what it's on is road or grass or oil. Now, of course, there's other ways we might want to try to define this in a more general way. We could make a helper function that returns, is this drivable? Let's do that just to show you how. Is tile type, let's make this, can drive over tile type blank, tile player hit. Okay, by the way, that previous code I had in the if statement I just cut with Command X on Mac, Control X on Windows. Because what I'm going to do is make a helper function. Private, meaning I only need to be able to see it within this class. Boolean, meaning it's going to return true or false. Can drive over tile type, int this type. Return, and here, that's where I just pasted Command V or Control V on Windows. This collected statement of, is this type either road or grass or oil? Because that's the type I can drive over. And you know, on the one hand, you can look at this and say, that's the exact same code. Why do you bother to do that? But this makes more semantic what that list of things was, where I was starting to collect a bunch of OR bars. So if I come back to it later, I don't have to wonder, wait, what property do those have in common? What does it mean here? This gave me a semantic label for it. And on the other end of the spectrum, if I want to add another type of tile I can drive over, I can now jump straight to the can drive over this tile type helper function I just wrote and add it to that chain with confidence that that's the only place that this function is being called from when that label makes semantic sense. And I press play, and I can drive over the oil full speed. I'm going to try to turn as I go over it. Nope, can't. Okay, I'm going to hold down left all the way through this oil. Nope. Left. Yeah, you can see it forces me to straighten out. Let's try it again with player 1 as well. It's kind of subtle, but you can, yeah, there it is. And again, I want to point out, these exercises are really just guidelines, just starting points. So, you know what else you shouldn't be able to do? Well, you probably shouldn't be able to stop. But right now, you stop just as easily as normal road. So, let's see here. Update position is on grass. Speed. You can see here where it's reducing the speed of our car. And we don't want to do that if the tile type that we're on is oil. I'm going to make a little helper variable just to make it more semantic. So if the type that we're on is oil, we now vote this will be true here in this update position. If we're on oil equals false. Okay? This way, if we're not on oil, the car won't slow down when it's not accelerating. See that? It's a much more oil-like interaction in which you can't easily stop on it. In addition to your inability to turn, you really just kind of lose control of your car while you're on it, which is, I think, appropriate if we want to have like an oily, tricky corner on our maze. Okay, so there was 512. Let's see for our next one, day or night themed tile sets. So by switching which graphics get used to draw the track, the same track can be depicted as being at either time of different, as being at a different time of day, a different season, or even someplace else like a different culture, climate, or planet. Duplicate the existing tile art, mark the copy files in some consistent way to designate which theme they are intended for, and adjust to redraw each tile to fit the theme. In-game, let the players toggle between the default theme and your new theme by pressing a key. When we later add support for multiple track layouts, we can connect different stages to different themes, but this simple key toggle works for testing purposes. Details. Define a new int value in the world file. Okay. Based on its value, load a different art set. In the key handling file, check for when a currently unused key is detected in keypressed using a comparison like if key is equal to u, and use that spot in code to change the theme int in addition to calling the function used to load track p image variables based on that theme value. It sounds like maybe it's going to be a lot, so let's take it one step at a time. One thing we've identified is we need to duplicate the existing art, mark the file as consistent way to designate which theme they're intended for. So here's all of our track files, for example. And let's just do night and day, because that's one that was kind of suggested there. You could copy and paste them again if you're in Windows. I'm just going to duplicate because I'm on Mac with Command D. Right clicking will give you those kind of options too. And I'm going to call these _night at the end of each. I use Enter key renames on Mac, F2 on Windows, of course, in case you like keyboard shortcuts. And now, just for consistency, I'm going to go back and I'm going to call these other ones day. So now I have night and day graphics. Okay. And by default, let's see here. Here's where we load the images. You'll see that these don't account for night or day. And what I'm going to do is I'm going to add a variable. We're going to have to put this elsewhere later. New int value in the world file. We'll just put a top level. Int theme set equals, let's say, 0. Final int theme set day. Let's make these 0. Night equals 1. And this actually allows us to be more explicit and semantic in our default. Because watch this, okay? String theme word so this way we can have a word which is going to vary based on the theme set. If theme set is equal to theme set day, switch case will make sense here too, but if else it works, we only have two different cases to deal with. Then let's make that become _day. Else, and again by process of elimination right now, if the theme set's any number besides day, let's just load night. And now we have the theme word in here. We can make that a part of our file name here in load image, using plus signs for concatenation and quotes to terminate and initiate the other strings. So before each PNG, we're just going to do a split. And so again, just to walk through what we just did here, if theme is set to day, when load map images gets called, then this _day is going to get added to this part of the file name. You see that lines up with the way that I've just named these files, with _day for day ones, _night for night ones, and likewise for _night. Now we want to toggle this when the person presses a key. So let's go to key handling, set controls, key pressed. We don't really need to deal with these like true false flags for like we have to worry about using keys as their buttons for driving cars by being able to hold and release gas, reverse, left and right for each player. But for changing the theme, we'll just have it happen in key pressed where holding isn't really an issue for us. And now what we want to do is we're going to call load map images, which is going to update the graphics. But then right before we do that, we're going to toggle theme set. Okay. We could say, for example, if theme set is equal day, then set it equal to night. And as good practice here, it's a reminder that 2 equal signs is for comparison, 1 equal sign is to set it. So this is only true if these two are the same, but it doesn't change theme set. Whereas this takes the value of theme set night, smashes it left onto the value in the container named theme set. Otherwise, it must already be nighttime. So let's go ahead and set it to day before we reload those graphics. So now you should let us toggle the graphics. And we haven't actually changed the image files yet. Remember, that's going to be an important step. But let's bump back over to our PDF to see if it has any tips for us. If you're looking for a relatively simpler way to generate a whole separate theme, adjusting the image's brightness and contrast can be a way to crudely simulate a different time of day. If changing time of day, a nice touch that can be done to show attention to detail would be switching the car graphics based on the theme as well, so that headlamps are only on, showing for the later theme. Switching car models for theme could also be used to put snow on top of the cars for a winter theme, though it's worth considering that a theme with snow in it might also imply that the player cars should handle differently in those road conditions. Well, first we just want to test it and see if this change works. We're going to do this in 2 steps. First, even though we haven't changed the graphics set, I'm pressing the U key to confirm it doesn't crash my program. So this code's probably happening. How can we be sure it's happening? Put in a little debug line. You gotta use a string, U key pressed. I press play. And sure enough, when I press U, over here in the console, you'll see it's saying U key pressed. That's our sign this code is being reached. This code's happening and it's not crashing our program. So far, so good. Now, before we go crazy and start replacing all the images, let's just replace one of them. Like, let's set the grass to be at night. I'm going to open that one up in my image editor again. And as I mentioned, there's all kinds of ways to deal with brightness and contrast, make something look slightly more at night. We could just pull up our brightness contrast thing, lower the brightness, play with contrast or whatnot. Another thing you can do to kind of simulate night, if I just take a dark blue, oops, I'm going to make it on a new layer. And if you just kind of paint a dark blue over things, it can also help kind of give it a murkier effect, which is simultaneously lowering the brightness, washing out some of the contrast, and giving it a bluish tint, which we expect from film. It's just part of how we see night. And so that's my 50% layer of blue. That might be a little too intense, but it's a starting point. I'm going to save that. And now let's just check if I press the U key, you can see the grass is changing. That's promising because it means the rest is probably going to change too. So let's go and open up all of our other ones that are night. Night, night. We already changed the grass. Oil, road, tree wall, and flag. Open up. And obviously, I mean, I'm trying to do something kind of quick and easy here just to show the point. Once you get this working in your code, it'd be easy enough to revisit doing a much nicer job with getting everything to look like it's at night. Okay, there's my night version. By the way, shortcuts here. So I'm creating a new layer down here with the button. And then I'm painting with my paint bucket. I'm creating a new layer so it doesn't have a transparency overlap with stuff. I'm then pressing V key to change back to my selection pointer. And then 5 to jump straight to 50% transparency. And then Command E or Control E in Windows to merge my layer down. So it goes back to 1, allowing me to Command S, save it back over the file. These are things once you've had to deal with a bunch of things in batch, you just kind of get in the habit of doing. Let's see here. And again, this is not going to be gorgeous, but it's going to work. And that's all of our goal initially, is to make things that work in a simple fashion so that then we can go back and give our attention to where it's needed later on in development. Okay? Having saved those images, now I'm going to press U. We get this kind of nighttime-ish look. And of course the cars are popping. So here's another reason why it's worth figuring out, should the cars look different at night than they do at day. Here they stand out awful bad on the blue tinted background. Our cars should also probably be blue tinted during night. So let's do it this way, okay? Where we change those car graphics. Fortunately, we still have the old green one from player 2. Let's go ahead and call this one player 2 day. I'm going to make another one, call that player 1 day. Once again, I'm going to use this trick where I'm going to borrow the car graphic from the original car 1. A little snappy way to make sure I get exactly the right texture area that I want. I'm going to select all, copy, paste it over it, right click on this, select pixels, change layers, copy, bam. So now I've got just my car pixels over this. So I have a player 1 day version. In addition to, I've selected there the car pixels for player 1's what's going to become night. I'm going to open up player 2 as well. Open with Photoshop. I'm actually going to do that same trick to select the right pixels. I'm going to paste the car I had, right click, select pixels. I don't need that layer anymore. Because now what I can do, since these are going to be our night cars because they have the headlights on, I can do the same trick I did before of creating a new layer, printing blue, 50%, merging down, saving. Okay, same trick here. New layer, painting the blue, 50% transparency, merging down, saving. Okay, and now I'm going to close those two files. I'm going to rename these ones that are tinted blue and have the lights on _night. Okay, and we've just got day and night versions now for each car. And here in our car graphics, I'm assuming we probably do this somewhere. Yeah, load image for the player. You'll see we're doing it where we initialize the cars. First off, let's go and replace those. We'll worry in a second about kind of like, all that matters for now is that this is not going to cause our program to crash. We have to give it any old image, because then we're actually going to overwrite that car's graphic based on the time of day. And what we're going to do is we're going to make a new function here, public void time of day graphic. Let's say update time of day graphic. This is going to kind of outdate the way we used to have to pass in a graphic name here. And in fact, we're going to go and we're going to see that through. Let's eliminate this section. We're not going to pass any argument into the constructor. Instead, so let's gut out this thing it's asking for. We're going to call this update time of day graphic function here, which is then going to check there we go. Okay, I see what the problem is. It's wanting to know whether it's player 1 or player 2, and that's why we used to ask for that value. Does the car not know which team it's on? It looks like it may not. So we're going to do this. We're going to say private string player slot number. Because we're going to do here equals which player. Now you might be wondering, why are we passing around a string as a number? Oh, we can make it an integer. Changes as I go. This is actually, of course, how most programming happens. So we're going to pass it a number, meaning 1 or 2. We're going to save that number. Comes in as which player. We saved as player slot number, which is going to be persistent on our class. So that then when we load the graphic, based on the time of day, we can do it differently, whether it's player 1 or player 2. Here we're passing in the 1 or the 2. And then, how do we check for it over here? We said if the theme is time of day, do one thing, otherwise do night. Okay. I'm going to copy and paste that same if-else situation. Oop. Trying a little too quick on the keyboard here. Okay. So what we figured out is that either player is going to be that plus the player slot number plus day.png. And if it's a nighttime car, then underscore night. Now you can also notice that this underscore day and underscore night are now repeated theme words across multiple files and multiple places. That's getting a little sticky. We may actually want to create an array of those things, depending on which theme we're in, that then instead of having these if-else chains, we could just use the word for the theme 0, theme 1, theme 2, and so on to automatically switch between the graphics. Now the last bit we're going to do is we're going to take this public function, which we declared public, so we can call it from outside the class. And we're going to call it on the cars when we update our graphics. So here when we've pressed U key was pressed. Here we want to update for each of our cars, which is P1 and P2, declare it at a global scope without any constraints, without being inside of a class in our main file. We can say P1 dot update time of day graphic. Same deal for player 2. And if that worked, oops, looks like I'm getting the opposite of what I wanted. See that? Aha! And I'm glad you're seeing me do this because this is part of how programming happens. We're toggling the theme after we updated the time of day graphic for the car. So I just bumped these down below. Now the theme is going to switch. Then we're going to update the graphics for the car. I expect it's going to look a lot better. Yeah, there we go. And now at nighttime, they have their headlights on. At daytime, they don't. And the car blends in better with sort of the blue tint that we have going for our night effect. All right. Well, so that's the introductory exercises. Now I want to stress that because the racing game is further along in the CodePak bundle, the introductory exercises are a little harder or more involved, as you just saw, for the racing game than they are for the other projects and the earlier projects in the CodePak. Of course, so we could get into the practice ones. There's many, many more of those. If I scroll back to the table of contents, those include everything from, let's see, Brick Breaker, Bomb Dropper. Right, so there we just did 3 exercises for the warm-ups. That was it for the racing game. Practice exercises including loading track lines as an array, track images as an array, collision at the front and rear of the car, laps with checkpoints, boost or nitro each lap, car-to-car collision, even just the basic, because right now the cars go right through each other, single-player option, in which player 2 movements will be random, transition phase at the start and end of stages, and race time based in real time. So again, what I wanted to show right there was just simply some of the warm-up exercises for the racing game included in the CodePak bundle. If you're interested in that, hobbygamedev.com/codepaks will get you there. I'll have some more videos for you in the future, but hopefully this has been helpful to those of y'all who've been thinking about doing something with CodePaks or just trying to figure out more about what's it all about. This little example here, I hope ground you some more in the kind of things you're going to learn from it. It's a lot of material, a lot of content. As I showed there, I've been doing this for a long time. Still took me a while, even just to wade through these 3 warm-up exercises for one of the 6 games included in the CodePak bundle. So it's Chris staying on for Hobby Game Dev. I really hope it's been helpful to you. If you got questions, let me know. If there's other sections of the CodePak bundle's exercises that you'd like to see performed in video solutions in the future, let me know by email. I'd be happy to prioritize those on my list. Thanks so much, and I'll have more content for you soon. Bye-bye.